It's 4:25 p.m. Eastern Standard Time on Friday, April 8th, 2016. You're looking at a live shot of Falcon 9 at Space Launch Complex 40 in Cape Canaveral, Florida. My name is Kate Tice, and I am a process improvement engineer here at SpaceX, streaming to you live from our Mission Control Center located in Hawthorne, California. Welcome to the first SpaceX Dragon mission of 2016. Today's flight of the upgraded Falcon 9 rocket is launching from Space Launch Complex 40 in Cape Canaveral, Florida, and it will be setting Dragon's course for the International Space Station. Under NASA's Commercial Resupply Services contract, this is the 8th SpaceX cargo mission to the ISS. Our capsule is filled with resupply articles and experiments for the ISS astronauts. Also aboard is Beam, an inflatable module or habitat that will be tested out on the ISS. More on that later on, though. We have rocket shots galore for you. Stay tuned.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop. Falcon 9 is clear to towers. GC, move to section 10.59 to secure the pad.
Stage 1 propulsion is nominal.
Falcon 9 is on its way to delivering the Dragon spacecraft to the International Space Station for its 8th Commercial Resupply Services mission. We are about to cross through max Q. It's maximum aerodynamic pressure. It's one of the highest stress states on the rocket. But keep in mind, you're looking at a 70-meter tall rocket. About the equivalent of a 25-story building going to space. And that exhaust plume is about 1.5 million pounds of thrust coming out the aft end of the first stage. You just heard them say that the MVAC chill has begun. That's where we've started to chill down our second stage engine, getting ready for ignition right after separation. This first stage will continue to burn for about another 20 seconds, after which we will have main engine cutoff, or MECO. About 3 seconds after that, we will separate from our first stage, and then the second stage ignition will follow shortly thereafter.
Critical moment in the mission. The second stage will now begin accelerating itself and the Dragon spacecraft into an orbit so it can catch up with the International Space Station.
Yeah, so the shot that you see on your screen there, that is the second stage engine glowing beautifully, a golden orange there as it propels Dragon to the International Space Station. You can even
see the coast of Florida just down on the bottom over there, right beyond the nozzle.
Yeah.
So,
one of my favorite shots.
No, there's a lot coming up in just a little bit here. The cheering you're just hearing right now means the nose cone is separated successfully from the Dragon. This is the aerodynamic cover that sits on top of the Dragon to protect it from the wind as it launches. The higher up we get, the less we need it, and it just becomes extra weight, so we pop it off and we don't need it anymore.
Exactly. So Dragon still has a long way to go, but what we're going to talk about right now is a little bit about the stage return.
So you're actually going to be hearing the crowd cheering a little bit more.
Yeah.
The first stage has a few different burn maneuvers to go through as it descends through the atmosphere to get towards the drone ship. So the first burn is the boost back burn. That's just about to happen in a few seconds here. The boost back burn is when the rocket turns around and kills off all its horizontal velocity, or enough just to make sure its trajectory lines up with where the drone ship is in the ocean.
Exactly. And then the second burn that we'll be looking for is the re-entry burn. And that's exactly as it sounds. It's whenever we fire the engines to slow the rocket down enough so that it doesn't catch fire as it re-enters the atmosphere. So that you just probably heard, boost back for stage 1 has just commenced.
So that'll burn for just a few seconds, and we'll hear another call saying that the boost back burn is completed. Again, this is great news for the first stage landing. The first stage doesn't have a heat shield like the Dragon, so it needs to slow down before it hits the atmosphere.
Exactly.
So the fast and hot atmospheric gases don't damage any of the engines, so we can reuse it.
Yep. And then the last burn that you'll hear us talk about is the landing burn. And if you've joined us on our previous webcasts, you're probably familiar with we try to bring you footage, and so we hope to do that again live as everybody else sees it here as well.
So stay tuned. A lot of fun stuff coming up. So we're just about to go into the re-entry burn of the first stage. This is when the first stage slows itself down just before it hits the thick part of the atmosphere, so it doesn't damage itself. Now,
go ahead.
So once the re-entry burn is complete, then we wait for the landing burn, and you'll actually be able to see the landing burn as it comes down. And that means
So what you're hearing now is the crowd reacting to confirmation that the re-entry burn has begun. You can see we're all super excited. Just a reminder, the primary mission to delivering Dragon is still nominal, still going well, but we are expecting our first stage to come back down and land on Of Course I Still Love You, located in the Atlantic Ocean.
And we do hope to bring you video. Now, there's a chance it may cut out, but we're pretty confident we'll be able to get some good video of the landing today. Now, just to reiterate, even if it's not a completely successful landing, every little bit of data counts. This is an experiment. It's not related to the main objective of today's mission, which is to get the Dragon to the International Space Station.
Absolutely. So the data is the most important part about landing these, the first stages back on the drone ship. So like we said before, if it ends in a beautiful ball of fire on our platform, that is okay. We're still going to learn a lot from it.
So keep standing by here. We'll get you some video really soon. Sounds like stage 1 is going through its transonic phase through the atmosphere. It means it's heading right down towards that drone ship. We're on track for hopefully a great landing right now.
So right now, we just